CEOs, I will introduce you.
I guess it's pretty warm here, so
Take that off.
more comfortable.
Okay.
Less formal.
Welcome to the Computer Security Seminar. Today's speaker is Leszek Lillian. He's from Western Michigan University, and he will speak on some thoughts on the Pervasive Trust Foundation for the future Internet architecture. Leszek.
Thank you very much, Professor Wagstaff. It's my pleasure and honor to be back at CERIAS again. CERIAS is, I'm 200 miles away from this place, but CERIAS and Purdue are always close to my heart. So it's even more pleasure for me to be here. I would like today talk about the very broad general issue. The primary motivation for me was participation in the Future Internet Summit and organized by the National Science Foundation. And among the people that were invited or selected was I would say about 50% were not architecture or network experts, but security and privacy. I always say privacy and security experts. So there are of course many summits on future architecture. I'm talking about the most recent one that was in October, and I have noticed many different approaches to that people proposed, which could be used as an underlying foundation or an overall basis for the future internet. I am most interested in a foundation for the security mechanisms. So maybe the title should say pervasive, be a little bit, narrower and say pervasive trust foundation for the security, and privacy in the future internet architecture. I would like to acknowledge two of my PhD students that contributed to this presentation, Adawiya Al-Alahneh and Latfi Ben Othman. I will pretty quickly cover the basics, goals of the future internet. Actually, some of you might have seen a presentation on that some time ago was given probably in the same media room by Dr. Landweber. And then I will summarize major issues of introduction to trust. And then I will present what I want to propose, pervasive trust foundation for the future internet. Not just trust foundation, but pervasive trust. And I want to analyze it a little bit and present to you the most critical obstacles that are in the way of trying to realize this goal of pervasive trust foundation for the future internet, or just for the security, privacy portion services of the future internet. As far as goals go, we'll quickly take a look at basic requirements challenge, designing future internet, and Genie Fastly design. This is based on the presentation that I have mentioned by Dr. Landweber here. Here is his view what should be the basic requirements for the future internet. And as you see at the very top, he placed that the future internet must be worthy of the society's trust. Of course, how he understands trust, how I understand trust might be different issues. However, on his list, trust is up there at front. And he considers creation future internet a big challenge. And of course, most people will agree that yes, indeed, it is a huge challenge to try to replace something that serves so many people so well, despite of not really being designed for the masses that it serves for. And one important issue is that we have a future internet NSF is asking for ideas and supporting a clean slate approach. A number of teams are already working. There are already centers working on that. But they are still looking for more and more ideas to present. The issue is basically a little bit like what the nature is doing. Try different approaches. Some of them will die, some of them will survive. Natural selection. One of them hopefully will hit the bullseye. And he then mentioned about the Gini facility design, some of the important things that Gini would already is using and that will be introduced in the future internet. Gini is a facility for experimenting with huge networks, are the notions of slicing, virtualization, and programmability. And again, he mentions here some of the major architecture ideas for the Gini, but you could as well say that, well, at least some of them should make it to the future internet. And the rest of them, and again, clean slate, secured network architecture. Let me now go and briefly try to say what is my view of trust, and yours might be different, or maybe you would agree with everything I say. Well, maybe with nothing. Anyways, maybe you have heard most of the statement that I'm going to present to you already. But anyway, it will be useful to go through some trust basics. First of all, the trust is defined in relation not only to a person, but also to a thing. So you can trust your car, you can trust your computer, and so on and so on. Of course, you can trust your software or not. Basically, using this definition, we can say that we can use trust in relation to every entity in a network, in the future internet or any future next generation network. Another important thing to remember is that trust is pervasive, and that's explanation why I use this word in the title and in my idea, is pervasive in social systems. Can you try to imagine a situation that you are in a situation worse than in a Wild West, that you have completely no trust to anybody around you? You have to always have, eyes. You have to really, watch your back, and you have to watch on the side. You have to always be ready to reach for your gun because you have absolutely no trust in anybody around you. Anybody who's around could be enemy. There are some, of course. So that's kind of one analogy. Another is some people have, some personality disorders, and if I'm using the correct term, and they distrust everybody. Some, the kind of the radical version of it is a paranoia, and they don't trust anybody, and their life is miserable. Our life without trust would be miserable. We use trust all the time. We use trust constantly in interactions with other people, with organizations, with animals, and artifacts, again, going back to the definition that it can be a thing that you trust. We use trust instinctively without thinking in it. You simply feel, it's like a gut feeling that you trust some people, distrust others. Sometimes it's based on some evidence, sometimes just on something totally vague and not justifiable in any formal way. If you look at the trust, for example, imagine a small village when everybody knows everybody. Every person that a villager sees has some trust value attached to his forehead for that person. Okay, you either trust them to some more or less, some degree. You distrust, villager distrust some people because they know those people, folks should be avoided. So this is a village is basically an example of a closed and static system. Assume that people who are there are no visitors or very few visitors. it's a closed system. People don't move out, and village is not growing quickly. In comparison, if you have open or dynamic system, you should use trust not instinctively and implicitly, but in open or dynamic system, you should use it consciously, not gut feeling, consciously and explicitly. Suppose that you move to a big city, okay, or just a town, okay, that is open, dynamic, like a university town. Maybe it's not big, but very dynamic. People are moving, coming in and out. And anyway, it's too large to know everybody. So if you look, for example, for a good dentist in a new town, you would ask your friends. Okay? Explicitly, you are trying to find who they trust, and if you trust your friends, you'll use a recommendation. Right? So now you treat trust, you have some conscious and explicit reference to trust. You might not use the word trust, but you say, hey, who is a good dentist? How do we establish trust? By interactions. You build trust by interacting with others, people, organizations, things, artifacts. And interactions, of course, there are different interactions. Could be simple transaction, complex collaboration. There are issues like how to establish initial trust. You don't know somebody at all. Person walks into classroom. Well, if I know it's a student from Purdue, I already have pretty high trust for that person. Much higher than for a person from a street, okay? Because it is, being a Purdue student carries with it a certain, positive qualities. That this is an example of trust of an organization rubbing off on members of that organization. There are many approaches known in the literature for trust acquisition. Here are just 3 examples listed by observation, interaction, using institution. I just give you example of a trust into institution or its reputation rubbing off on you. We can look at different elements of trust, how trust, reputation are related, and what is the value of reciprocity in building up trust, and how such relationships can be reinforced. These are all interesting subjects. Suppose now that in a computing system, I want to know what value of trust I can give to a certain service which I intend to use. I might have my own experience, first-hand experience with that service. I use that information. I might have reputation information from others, second-hand experience. I have to somehow put together that information. And that second-hand experience could be from, like BBB database or, Better Business Bureau database or some other consumer information places. I put them together, and I have to calculate a single trust value, let's say, to make things simple. Let's call it, it might be a vector, but let's say a simple value of trust level that, in my eyes, that service earns this trust rating. And here are different ways how you can calculate that overall trust. A few examples of different approaches. The typical approach to trust nowadays, and we'll be talking about that in a moment, is that people typically don't look at the comprehensive, broad foundation of trust throughout the whole system. They basically build piecemeal trust management mechanisms for individual security services or mechanisms. We're talking here about security services, not all services, but you could probably say the same thing about many non-security services. So you have, for this mechanism, such trust values, trust such and such. The issue is now if you try to build a federation, let's say, or build another system on top of those individual systems, subsystems, this issue of interoperability of trust. Trust degradation recovery. Well, if somebody trusts you and you disappoint her, you lose trust very quickly. right? Somebody trusted you that you will not cheat. You cheat. Oh my, terrible transgression. It will take a long time to gain again the same degree of trust. So, fast degradation. So that's what we had on the previous slide. Fast degradation and slow recovery of trust. So, if trust is so pervasive in society, why not to use it? Pervasive trust as a paradigm of computing. Now, again, I'll talk a little bit more about that, but some people see trust as a component of security. I see trust as an overall foundation of security. Okay? Not trust in the small, and I'll use the term in a moment, but trust in the large. So trust is already used in computing systems, but mostly, as I say, in a piecemeal fashion. What the claim that I'm making is that trust should be even more pervasive in computing systems. So, some of the challenges of extending the trust basis might include defining trust for also artificial entities, for more artificial entities, and also to make explicit what are subconscious uses of trust by human users or by non-human users. Dimension of trust are competence and intention. Sure, you trust your mom. She has the best intention. But she's not the airplane pilot. Would you fly with her? Would you trust to fly with her? No. Neither would she trust you to fly with you unless you are a pilot. So, competence and intention are two levels of trust. Second thing, trust is not a binary. It's not like I trust somebody or distrust. There are different degrees. Binary is just a simplification, which might be good in some situations. Good enough. You have to trust somebody. You can't trust everybody, but you have to trust somebody. If you don't trust anybody, that's the situation I already mentioned of a complete paranoia of a miserable life or a completely inefficient system. Trust is asymmetric. I can trust you more than you trust me. Trust is also, well, we already kind of goes with that. If it is asymmetric, well, we're talking about it's also bidirectional. Who should you trust? Anything can be trusted. Trust, what is a relationship of trustworthiness and trust? Trustworthiness is a very often mentioned thing. Trustworthiness, if something is trustworthy, it implies it's usable. If it's usable, you use it more often, you build up trust. So we might consider in much more detail those relationships, but enough just to mention it now. If you try to use trust, all its aspects for every, let's say, security mechanism or security service, you will basically create a system that's terribly inefficient. Trust includes so many different factors, criteria, viewpoints that you have to basically, whenever you design something, select what is appropriate for what you're doing. You should avoid and also when you build up trust, you should avoid demands for too much evidence. So, you don't trust people unless they give you more and more evidence, or you avoid asking them, they give you too little evidence, then they don't trust the system because the system appears to be lax. So, many other research issues that are summarized briefly on this slide. It's not to study, so just to show how many different, basically in each column you have one or two subtopics with references, so you can see, for example, even three subtopics here, so you can see how many different issues are very diligently studied. Let's take a look now at pervasive trust foundation for the future internet, or at least for its privacy security portion. We know about, roughly from the NSF summit, people were saying, okay, we are in the second Internet 2.0. Internet, future Internet could be called Internet 3.0. try to compare the design or Internet 1.0 with Internet 3.0. The original Internet were designed for closed communities and systems. 3.0, anybody can use it, completely open. Prevalent trust level, well, if it's a closed community, you can, it was a research community, people could trust each other, high trust. Internet 3.0, anybody can use it, trust is low. So if you have environment which is highly trusted, you can use no security services or weak security services, because the risk is very small in a highly trusted situation. Here, the reverse. You cannot use weak or no security services. And for Internet 1.0, if we had low trust situations for a given subsystem, we would just design for it a trust management subsystem that would support just this small thing. It was like patching the system with a low trust patches. For Internet 3.0, I believe that we need system-wide trust foundation. I already said that. If we have this overall foundation of trust, it will be easier to establish a trust value for any new user, either human or artificial. It will be easier to keep it consistent and fair. It will be easier to perform trust management, like, for example, calculating the overall trust value based on first-hand and second-hand information. And it will be easier to extend to cooperate better, because the trust relationships will be more dense, so less obstacles to cooperation can be established. I want to present here a basic reference model for a trust foundation. And actually, if you look at the ISO layers of networking, you could say that, okay, in future Internet we will have pervasive trust foundation. Here we have security services on the same foundation, and of course each of the security services can potentially serve each of the layers. Now, maybe one thing to mention is that confidentiality, integrity, availability, those three, CIA, this is a classic definition of not trust but security. I made a mistake here. So when people defined security years ago, they would say security is confidentiality plus integrity plus availability. Since then, we have seen at least 2 more extensions. Here is alternative view of a basic reference model. Actually, that's the one presented at a summit. I miss here a reference. Instead of layers, we have those generic levels that you can identify in the system: hardware, operating system, network, application, user. Now, I hinted at that we need to distinguish trust in the small from trust in the large. The former supports individual security services or small groups, maybe 2, 3 services. Trust in the large is meant to support all security services or many of them, large group. Basically, I say, okay, so trust in the large really is what I have called moments ago, pervasive trust foundation. You might say that it's equal, or you might say that pervasive trust foundation is one of the ways looking at trust in the large. I do the former, I put the equal sign. Whenever we deal with trust, we have 2 entities that are involved: service provider and service consumer. There must be trust relationship one way and the other. We might say that we might try to model the service provider would receive service request, would evaluate the risk and benefit of providing service, would get the trust rating for the requestor, and would make the decision accept or decline. There are some cases where it's easy to make a decision, very easy. If I'm a service provider and my benefit is 0, I would say go somewhere else. Okay? If I'm commercially minded, okay? Not altruistically. If there is no risk and benefit is even very small but positive, I'll say yes. And there are a few other things that it's pretty, here is a table that we have 3 levels, 0, low, high. And, in some cases, it's very easy to make the decision. As you see, out of 9 cases, 2 cases are, well, context dependent, not so easy to decide. Other 7 seem to be easy to decide by the service provider. Service consumer, here's the model of a service consumer. Service consumer has certain need for security, has a number of possible services available to him, evaluates risk-benefit using a given service, their trust, and makes a decision whether to select a given service or not. Now, so these are simple models of using trust by the requestor, the consumer and the provider. Trust can be used to enhance producing and consuming messages for every security service group. I say group because there are a few services in confidentiality, a few in integrity, and so on. So each of those represents a certain group of security services. We can look, security services are supported by security or realized, implemented through security mechanisms. So, for example, if you have Pervasive Trust Foundation, here you have integrity services or integrity group of services, integrity service group. They can support any of the layers. There is here a certain entity that looks like this. You have integrity security service, which is supported, implemented by using integrity security mechanism specific to support this integrity. And this integrity security mechanism, if we want to, uses some trust in the small number 1 in a piecemeal fashion. And you might have another, small white block in somewhere here or here or here, a lot of them, each one might have its own TIS. Well, in our model, we want all those TISs, those trust in the small, we want all of them to relate to TIL, trust in the large. Here are my claims. And this is, of course, highly debatable. You might disagree. I would be very happy to hear about your arguments against and for. Okay? Some people dismiss saying, oh, having a trust foundation, I'm so tired about hearing about trust, probably because they've heard about 100 different trust in the small solutions. Okay? And they are tired of trust in the small, and that's why don't they appreciate trust in the large? Because they think it's the same thing. They confuse the things. So, well, that will be actual next claim. But the first one is that security, if you don't use trust as your basis of a foundation, basically what you want, if you say, no, I don't want to use trust at all, you would say, you want to build security despite of trust. Instead, I propose, hey, maybe you should have security thanks to or because of trust, not despite or without. This is what I have mentioned, kind of, talking about the example for the previous case, I jumped to this one. Many people confuse trust in the small with trust in the large, and that's why they deny the need for pervasive trust foundation. They are tired of those theses. Too many theses. Oh, another one, forget it. Well, it's not thesis, it's an overall thing. So TIL will be the focus, is the focus of this presentation, is the focus of this presentation. Of course, we also will mention TIS. What are the use choices for pervasive trust? You can use it either consciously or ignore it, well, in a kind of, unconscious way. If you use it consciously, you can use it explicitly, considering a trust level, or implicitly. You might say, well, I know that this is a highly trusted environment. I can use this service. I don't have to calculate the trust degree. This is trusted. I have a lot of evidence, a lot of, kind of even gut feeling as a designer that I don't need to deal with calculating trust level. I just use trust implicitly, maybe just boiling it down to binary trust or not. If a person ignores trust, well, might be lucky, by pure luck, there might be no adverse effects. So you build a mechanism ignoring trust, might work. For one reason or the other, maybe just pure luck. Oh, of course, there is a possibility that if you ignore trust, you will bear the cost of that, not ignorance, of that ignoring. Next set of trust. If you ignore trust, you will experience higher risks. Next claim. Trust can be used implicitly only after making conscious decision that this is a good assumption, that there is a sufficient trust level. So I'm writing a subsystem, say, okay, I wrote all those components, or my people I trust wrote all those components. I don't need to assign trust levels to every component. They don't have to kind of, look at each other explicitly through the trust value. Implicitly we can assume, okay, we have enough trust for those to by assumption, without detailed consideration of trust. Claim number 5. Having trust in the large is necessary for comprehensive and consistent consideration of trust. I guess it kind of goes back to the definition. Well, that's what how I define TIL. So yeah, the proof is in the definition, kind of, you might say. Of course, I kind of say it with tongue in the cheek. You should have some arguments to prove that claim or to support that claim. Claim number 6. Trust level, as I have mentioned, is context dependent. You are receiving you are a, let's say, provider, you receive a security service request. Now, depending on the trust level, you might decide that very strong security service has to be used, heavy duty, heavyweight, or you might say trust level is so good, so high, that I can use very low-key, low-level, lightweight security service. In general, strength of the security service is a function of trust level. Now, we know that security service is supported by security mechanisms, so you can say kind of similar thing about, well, if I use this security mechanism to support this security service, I have this trust level, similar considerations will apply. All right, so these are the claims that I'm making, and I would love to hear your arguments. I would be happy to receive it through email or any other civilized way. Okay. Security services, we already defined them as CIA-AANN, confidential integrity availability, next row. And I already mentioned. So we are at the moment, we are typically, this actually comes from a standard, this list from a standard, ISO standard listing security services. So this is a current situation, current state of the standard. The question mark is, well, we'll have new security services for future internet? Probably. Somebody will come up with something, probably. Okay, we have seen this picture. Here are some definitions. Now, I try to say, okay, so we have authentication, access control, confidentiality, integrity, non-repudiation, groups of services. At which network layer are they needed? And shaded area says needed. So, authentication needed application layer, transport, and network. Okay? Confidentiality group, look, pretty heavily, only not on session layer. And that will be mentioned later. Basically, the standard claims that security services at session layer are not needed because they are covered either by at lower or higher levels. Okay. Non-repudiation group only at the application layer. Here is another view of that, more detailed, because on the previous slide we have seen only groups of services like authentication, access control, confidential integrity, non-repudiation. Here we see subgroups, or you might say elements, whatever you want. Okay, maybe there are smaller elements within that. There are at least sub-elements of. So again, a little bit more detail. For example, for confidentiality, you see that traffic flow confidentiality is not needed at the presentation layer, and so on. Definitions, which we can skip now. If you go through the slides later, that will be something that you might consider useful. Here I'm reversing that. Actually, this is easier way to read it, because now here you have services, service group, and services listed, horizontally rather than vertically. Well, here you have network layers. Just a different view, easier. And I'm mentioning here the ISO standard. Whoops. ISO standard name. It's ISO 7498, which lists all those services and suggests where they should be used. Now, let's take a quick look at security mechanisms that serve all those different services. Here is a sample. The standard doesn't give a big list. We went to a paper and found an example of a sample list of security mechanisms that support security services. Here is an example list. Okay. Of course, now you can say which mechanisms are needed by which layers. Mildly interesting. Which mechanism support which services? More interesting. And again, a bunch of definitions. We started looking at some simple basic trust considerations for different security service groups. Authentication, SSG, access control, and so on. Let's take a look at the first one. When you look at trust consideration for authentication, you find out that traditional authentication relies on trusted third party, TTP. Certification authority, registration authority, right? Optional, but typically used. If you have infrastructure-less network without TTP, you can introduce these are TISs, right? Trust in the small. Pretty good privacy, trust and clustering-based authentication managed on special mechanism, TISs. And other services, confidential integrity and authentication provided by cryptography, digital signatures. You can take a look at each group, okay, and kind of conclusion is that in all those groups, all security service can, maybe don't have to, I don't know, should be question mark here, I'm saying but don't have to, but yeah. They can be built based on just those security mechanisms, digital signature and digital certificates from TTP. So it seems like this is like a minimal set of mechanisms that can cover, well, maybe not, maybe you need other mechanisms to do it more efficiently, but they, at least in a principle, they can cover, those two security mechanisms can cover the needs of all security services. What could be interesting, interesting topics for studying security services, and security mechanisms? We already looked a little bit, but of course much more is needed to look at trust considerations for individual security services. We looked only at some, but in general people looked at many of those. For future investigation, few interesting questions. How to facilitate development or foster development of trust relationships, because the more trust relationship exists, people can find, can basically increase their collaboration using the high trust connections. How well can we build trusted systems from untrustworthy or untrusted low trust components? We succeeded beautifully with building reliable systems from unreliable components in the area of computer reliability, right, or reliability in general. Can we do a similar thing, succeed so well, also doing this instead of with reliability with security? And of course, static trust consideration for each security mechanism, and also add PTF-based privacy. I told you that I typically usually say privacy and security, not security and privacy. I think privacy is extremely important. It might kill, any application if it's not provided appropriately. We might need PTF-based privacy services and privacy mechanisms. That's another big area to study. One more, in addition to claims that I made and presented to you, another thing that is very important is to realize that I want to present to you are the obstacles that are facing those that would say, okay, philosophically I agree with the idea of PTF. It makes sense to me. Nobody proved that it's bad. Nobody proved it's good. Let's give it a try, okay? That is totally good, that is best. Nobody proved it's really good. Nobody proved it's really bad. Let's try it. What are the obstacles to implementing? And the second question is, what are some ideas or rules, basic ideas for efficient PTF implementation? It seems that there are two major obstacles for realizing systems based on the pervasive trust foundation. First one is getting acceptance for the PTF principle. Okay, many people who say, well, you should not go this way. No, I don't accept this principle. No, you should not go there. When you ask them why, say, well, because it's inefficient. So actually, most of the people that say no are using the second argument. You cannot do it efficiently. So if we can show that it can be done efficiently, automatically this subgroup of the no acceptance group will come to our camp. Now, obstacle one I see is not really that material. It's not that tangible. It's based on belief. I believe it should be tried. Somebody believes, no, it shouldn't be tried. Where are the proofs? No, you cannot prove it. It's more like belief. Address obstacle two. It was more critical because if you succeed, it will remove obstacle one. It will be more critical and more fruitful, right? Because if you eliminate obstacle two, you also eliminate obstacle one for many, many people. There still might be some that, for some reason, say, no, it's efficient, okay, but no, don't use it. So, obstacle two is that PDF is too expensive. Let's take a look what, might be possible ways, and it's by no means a complete list. What are the possible ways of reducing perceived PTF usage costs? Because this perception might be totally wrong. But people say, this. First of all, there are some inherent cost savings thanks to using pervasive trust foundation. Second, additional cost-saving approaches and techniques can be devised to bring the cost down. And third, hey, you say that PTF is costly. What about the no PTF approach? Let's try to compare them. Maybe you'll see that there are those costs that you claim are in PTF. I'll show you, in a no PTF you have those costs plus more. Or at least, close enough. Inherent cost-saving properties. Here is my list. Let me just, mention a few from this list. For example, we already said that security service that is selected to satisfy a certain security request should select a service that is a function of a trust level. Low trust environment, heavy duty security service. High trust, low or lightweight, right? So instead of using heavyweight services, security services for all situations, use lightweight security services in high trust situations, sufficiently high trust. Don't use, one shoe fits all, right? Make different shoes for, for different people. Low trust, if you don't know what the trust situation, sure, your default might be heavyweight service. And then there are other detailed elements that I'll scan through because of a time limitation, but you can go back and take a look at them. Economies of scale is one of them. PTF is comprehensive. It can give you comprehensive feedback. TSIS can give you feedback, sure, but TSIS give you partial feedback. Maybe sometimes conflicting because this thinks so that TIS thinks in a different way. Here you have a comprehensive. Okay. In the second category of additional cost-saving approaches, you might, for example, leverage enclaves that rely on implicit trust. Hey, you have you might have within your system, you might have high-trust enclaves. In those enclaves, used lightweight security services. So we are in the Wild West, but here is our small town with a fantastic sheriff. You don't need a gun in that town to be secure. There is another technique for identifying enclaves that rely on implicit trust, and there are those other elements of this category. Again, you can take a look at those. The third category was comparing cost of PTF approach with the cost of no PTF approach. I'm saying, hey, overhead. There is an overhead even if till PTF is not used. So, my summary is just this slide saying, hey, well, that's what we covered. And actually, I should say that the most important contributions of this talk, as I see it, and I humbly, will be looking for your comments and feedback, is that I have shown you claims, those claims, 6 claims, pretty specific. You can now argue for or against them. And I also, another important thing is part 4, when I shown how costs of PTF can be reduced, or at least how they can be compared to the no PTF costs. So thank you very much for your attention. And we have 2 minutes and 43, 42, 41 seconds left. Thank you very much.
Do you have any questions?
So I was either so clear or so unclear, but once again, I would really appreciate your feedback. Some people that work for years in that area have already some skewed, way of looking things. It's like, reading your paper 20 times before submitting to a conference, you stop seeing errors in it or inadequacies. You are still should have pretty fresh look in the most positive meaning of the word. So if you have any comments, please be so kind, email to me. Just say WMU for Western Michigan University on Google, WMU or other browser, WMU Lillian, my last name, and if you do this, WMU and Lillian, you will find my web page and you'll find my email address. So thank you so much. I hope to hear from you.